Testing 1, 2. All right. Okay. We are live. Today, we are working on some exorcism.io exercises. Let me just pull that up here for you guys to see. All right. So we'll be working on this one. I think this is done. This is, yeah, okay. So protein translation is the first one we'll try. And if there's enough time, and we can work through that one, we'll try another one. So what do we need to do? Protein translation. Translate RNA sequences into proteins. RNA can be broken into 3 nucleotide sequences called codons, and then translated to a polypeptide like so. Okay. Basically, split up the string into 3 character substrings. Okay, sequentially, is what I understand from this. Codons, which becomes a polypeptide with the following sequence. Protein methionine, phenylalanine, serine. Okay, there are 64 codons, which in turn correspond to 20 amino acids. However, all of the codon sequences and resulting amino acids are not important in this exercise. Good. If it works for one codon, the program should work for all of them. However, feel free to expand the list in the test suite to include them all. I might not do that. There are also 3 terminating codons, also known as stop codons. If any of these codons are encountered by the ribosome, all translation ends and the protein is terminated. All subsequent codons are ignored, like this. RNA 222, AUG, UCU, UAA, AUG. Yeah, okay. Note the stop codon UAA terminates the translation, and the final methionine is not translated into the protein sequence. UAA is the stop codon, so codon UAA, UAG, and UGA are stop codons. Learn more about protein translation. Setup. Go through the setup instructions for TypeScript. Okay, no, I know all of that. Okay, let's give that a try. Let us download our exercise. Let's see. Exorcism. Done. Protein translation. Yep, okay. Protein translation. Did I not type that in correctly? Oh, TypeScript. Okay. See, TypeScript. Protein translation npm install. And let's take a look at our tests. Well, okay, what are they going? So it's a class with a static method, proteins. Take takes parameters, returns whatever we want. What are they expecting? They expect us to pass in, okay, a codon, I think it's called, and return a, what are they called? Codons, and return a protein name. Okay, so it's basically just a mapping thing. I think very similar to the DNA or RNA transcription that we were doing the previous time around. Okay, so let's do this. Well, let's first run our tests, make sure everything is hooked up properly. Alright, it's failing because we don't have any proper method signature, I guess. So let's do that. Codon is a string. For now, let's just return our codon. Run a test. Okay, compiled properly, but it failed because it's expecting, oh, it's expecting an array, I think, containing a string. Let's go take a look. To equal expected, yeah, it wants it in an array. Why does it want it in an array? We only ever, oh, sometimes we return more than one. Oh, of course, yes. Okay. So let's do that. Return an array with, let's see, if getting AUG, return methionine. We're going to pass that test. So easy. Oops. Okay. That's a little bit of cheating. What did I do wrong? Codon is declared, but its value is never read. Oh, you little. Okay. Guess we're gonna have to do something with this then. All right, so all we really need is some kind of a dictionary. Let's go take a look at what I did for RNA transcription. What did I use? An enum. I used an enum. That's interesting. I don't know that that's the best. Well, it's, yeah, sure. Why not? Probably would make more sense to use a map. I need to be able to iterate through it. Is that what I was doing here? Nucleotide and DNA nucleotides. No, I didn't really need to iterate through that thing. Just used it as a... I don't know why I used an enum. Let's try it with a map. I think that would make more sense. And we're gonna call this protein, codon to protein. That's what we're doing here, right? Let's call it protein map. Yeah. Protein map. I think would work. New map. String, string, key value pairs. I wonder if I can just, because how can I initialize that? I don't use maps often. Let's go take a look. MDN map. I mean, I could make it a simple object because we're using strings. Why don't we do that? Keep it simple. We could probably just keep it simple. Refactor if need be. For some reason, let's just copy this here. What? Okay. All right. Just for reference purposes, I'll put it here for now. Let's see, what's the shortcut for code blocks? Shift Alt A? Yes. Oh, I'm getting good at this. Okay. Oh, didn't keep the formatting though. A little bit more. One more. Yep. Should work. And here we go. So we basically need to, can I just copy this? Then I'm just gonna have to, oh no, that's not gonna work. So you're going to be on a separate line. That switch statement would have worked too, I guess. A switch statement could have made sense now because we've got many of this. Nah, just keep it like that. It's not horrible. Tedious work. UCG. Sorry. So this is leucine. Serene. UAC. Get rid of this here. Okay. Almost there. 1. And now this and this, like that. Oops. I don't know if there's a faster way to do this, but I'm done anyways. And this, like that, like that. Boom, okay. So we have our protein map. I'll keep that for now. Now that we have a protein map, we can return a new array. Dot map. No, that doesn't make any sense at all. So right now we only have one codon, so let's keep it simple. We're going to take a look at our codon. All we need to do really is return. Oh no, it's got to be in an array, so. Alright, let's just do that. Return. Here's our array. And protein map. This is going to be our key. Doesn't like it. Why? Element implicitly has an any type because type has no index signature. Yeah, now I remember. It's the index signature thing that I couldn't remember how to do. And that's why I ended up using an enum. You know what? Why don't we take the time to figure it out this time? How to do index signatures. TypeScript. Index signature. Yes, please. Okay, I'm not gonna. Index signature. Thank you. Oh, I need to make an interface first. It's gotta be a way to. Let's do it right as we are declaring it to. Come on. Maybe. So this should be our interface. Key. String. String. It doesn't work. Seems silly to have to make an interface just for the one. But for any Mm-hmm. There we go, declaring an index signature. Ah! Okay, here's the syntax we need to use. Just copy that here so don't have to go back and forth. Couldn't figure it out. So what we need to do is this. Using key, string, string. I think that works. How does it type this? Key, string, string. Yes, okay. Business. Let's take a look to see. So basically we're saying type object and the key as a string, an array of keys, right, that are of type string, and the property is always a string. Yes, okay. Let's run our test. And it passes, yay. I think this is better than using an enum for this kind of thing, personally. I think we ended up using the enum last time just because I couldn't figure out how to get the typing properly for the index signature of an object. Okay. Our next test should also pass with our naive implementation. They should all pass as long as it's only one codon at a time. We're gonna run into trouble once we start getting more than one codon at a time. And we're gonna need to split up our here, let's just open this up. We know it's gonna work. Basically have a test for all of them, I think. Sure looks that way. Oh, okay, that's gonna fail, so we'll deal with that in a second. Let's just first make sure our dictionary works properly. Yep, okay. So now this is gonna fail because it's gonna return stop, but we're, no, not this one. Let's see, this one here. It's going to return stop when in reality it should be returning an empty array is what they want. This is all basically the same test, so we can all activate them, run them to see that they're going to fail. It's going to say we're expecting an empty array, but you're passing in an array with stop. That's right. So how do we fix this? We're going to need to check for stop. Ugh. Oh no. Instead, I could probably just make this an empty string. It's expecting an empty array though, not an empty string. Yeah. So let's keep the stop in there. We're going to need to make a check. So let's evaluate this first. We'll call this const protein. equals our thing here, that, then if protein is equal to stop, then we want to return an empty array. Otherwise, let's put that protein in there. Run the tests. And we're good. On to the next tests. What are we looking at here? Sequences of, so I need to split that for every 3 characters. Okay. How do I do that? How do you split a string every 3 characters? Let's think about this for 3 seconds and then Google it if I don't come up with a good idea by myself. I could do this. Codon, which is a string. We could turn it into an array. Oh, no, how about this? We need to get from a series of, yep. Let's do that. 4. Yep. 4. Unless I just do from codon, which is going to split every character into an array, and then I do no, that's no good. I don't like it. Don't like it. There's many options here. We could turn it into an array. We could just use a for loop. Either way, I kind of feel like we should get an array of those codons and then map. But then again, what if we get this? Okay, yeah, this will become our mapping function. So it would make sense to make an array. So how do we make an array of our codons? So let's do this. New array. Yeah, okay. Let's look it up. Somebody has done this before. So split string every n characters, but not in Python, in JavaScript. There you go. JavaScript, elegant way to split string into segments and characters. Ooh, it's an old answer. This is newer. So this is exactly what we want. String, console log, string.match, some kind of crazy regex thing. Regex that I don't quite understand. This is global. This isn't this. What's the dot again? It's everything, I think. No? Anyways, so that's an option. Let's see if anybody else is. Substring I plus 3. Oh yeah, what is substring? I didn't think about that, but I think it's actually deprecated now. MDN string. No, not replace, just string. Oh, it's okay, so substring's good. Returns a part of the string between the start and the end indexes or to the end of the string. Index start, so I would have to loop if I use that, right? That's what he's doing. I think I much prefer the match. Because, right, match returns an array. Yeah, that's what they're using here too. Except it looks a lot more complicated. So how about this here? For these things, I like to go to this cool old website, Regexer. So what's the dot? I can't remember what the dot is. Dot matches any character, right? Except line breaks. Yep, we don't care about line breaks. So what does this guy do? Dot, and then when you put things but in bracket, I think it's sets. You're making sets, right? Anchors, no. Groups? No, that's not it. Escape characters, no. Look around, nope. Quantifiers, yep, quantifier, what does that mean? Matches the specific quantity of the previous token. 1 to 3 will match 1 to 3. 3 will match exactly 3. 3 will match 3 or more. So by doing this, we're saying any character match 1 to 3 global, and then you keep doing that over. Okay, I think I get it. If your string may contain new lines, it doesn't. If your string is empty, it shouldn't be. So let's go with that. Seems simple enough. Thank you, Stack Overflow. So codon dot match. Shove that in there. Whoops. Just the regular expression will do fine. Thank you. And let's call this const codons. There you go. Codons. Oh, there might be a better name for this. Let's go back to our problem definition here. It's an RNA sequence. So really, I should be calling this RNA, or RNA. What would be the proper RNA? Just RNA sequence, like that sequence. There we go. And then let's call this codons. Codons are equal to the RNA sequence. Well, not equal, but is assigned. Okay, so this should work. Then what? We need to return an array. Not condons, codons. We need to return an array. So we're going to map. We're going to return map. What am I doing? Codons dot map. Our mapping function is going to be taking the value is the codon. What's it going to do with that? It's going to do something similar to what we have here. So first we do this, then if the protein equals stop, we return. Oh, that's an interesting problem though. How do I stop mapping at that point? Is there even a way to do that? So now I'm beginning to think that maybe a reduce might be more fitting here. Let's just finish this for now. Pretty sure we'll pass the test. Codons. Why doesn't it like it? Codons. Object is possibly no. No, it won't be. Why would it be? Because your type 2 regex maps us into null. Okay. I could just typecast it and say that codons is going to be an array of strings, which it should always be. Is that right? And then, how about this? What? An array of string. Yeah, that worked, I think. Parentheses are required around the parameters of an arrow function definition. Okay. Mr. T.S. Lint, Nazi. I aim to please. So, oh, our test failed. One of them tests. One of them. Which one? Which one? More than one? But no, the three of them. The three of them failed. What? What? Our array returns undefined, so obviously this doesn't work. Oh, translate RNA strand into correct protein list. Fun. That worked. Interesting. Ow. So these didn't work. Why? Oh, okay, that's our stop problem here. So whenever we encounter stop, we need to return an empty array when we encounter stop by itself. What are we doing right now? If we get stop, we just return. We return undefined. Is that what we return? Am I to understand that we're returning undefined? We are. Well, that's interesting. That is very interesting. What if I return null? How would that show up? Yeah, it'll just show, yeah, it'll shove null in there. Same problem, yeah. But we need it to be empty. So I basically need to say skip. And I don't think you can do that with map, can you? Back to our trusty. Don't need this, don't need this, don't need this. So I need MDN array map. I don't think there's a way to skip over that would be counter to what mapping is. So I think I will use reduce instead. Mapping an array of numbers, mapping generically, tricky use case. Yep, let's use a reduce then. Reduce, what we want is an array. So our previous, or let's call this, what are we returning? An array of proteins, so array. Well, let's just call it proteins then, proteins and codon. Cons protein, we get our protein. If the protein is stop, let's deal with that after. This is the most common case, so we want to proteins.push our codon. Oh no. That's not our protein, yeah. Okay, protein. Missing the dot, protein.push. Push proteins. Okay, proteins.push our protein. Argument of type string is not assignable to parameter of type never. Why? Because you let's see, new array maybe. Would that fix anything? It seems to. Interesting. Proteins, now what? Argument of type proteins any, which is better than never, I guess. Return number null. Oh yeah, right. Okay, we need to deal with this. If the protein is equal to stop. Wait a minute. Not even sure there's a way to get out of reduce as well. Don't tell me I'm gonna have to use a good old for loop for this. Unless I use a flag, which is, what have I done? I could just use a flag here. Const stop is equals to false. How elegant. Oh, it's got to be a let though. Stop equals false. So if the protein equals stop, we flip the switch. Stop equals true. And then check if stop is equals to true, then we just don't do anything. Keep returning our proteins until the end. It's not very efficient because I keep going with my iterating through the codons even though I'm supposed to have stopped. So really this isn't the right way to do this, but let's see if I pass the test though by doing that. So if stop equals, what's wrong with this here? Assignments and conditional, oh, yep. Okay, so if stop equals true, we just keep skipping it. If protein equals stop, we switch it to true and we return proteins. Alright, I think this should work, at least for passing the tests. And it doesn't. Wow, actually, now we're passing our received one. What? How am I getting a number? Getting one everywhere now. That is hilarious. Insane. Let's think about this. We've got our proteins. No, we've got our codons. Okay, which is an array of 3-character strings. Then we reduce that array to another array. We start by getting the empty array, proteins. We get the first codon in our codons array, map it to a protein name here. Good, so now we have a protein, which is a string. Now we check our flag. If the stop flag is on, we just return the array that we've accumulated so far. Yes, that's correct. And then that would be it. Otherwise, we keep going. If the protein is equal to stop, then we flip stop to true, and we just return the protein. And that would be it. If none of these are true, we return proteins. And that push, we add the protein that we just... How the heck am I ending up with a number? And not even the... Oh! No, I am returning the... How is that? How is that even possible? Debug time, except this thing's not hooked up for debugging. So console log time. Let's see first. Let's make sure that our codons, we're doing that properly, but I'm pretty sure we are. Let's take a quick look at this. Yeah, looks good. And this is split properly, so problem's not here. We knew that though. Are we getting our protein extracted properly? Pretty sure we are. But let's just make sure. Yeah, it is working. Okay. Then I am curious. Let's see what we get on every, in terms of the accumulated proteins array, because I think that's the problem. Problem is clearly there. All right, so we're getting an empty array at first. Oh, and we're also having some kind of So all our console logs are at the end, right? Okay. And at some point, proteins, we're trying to push the proteins and it's not even an array. How is that possible? Not sure. So we're getting an empty array, an empty array, an empty array, an empty array, an empty array. Oh. Oh. Of course. I'm not actually returning the proteins. I am, because push returns something, right? Whatever. This is what I need to do. Yep. Way to go, Phil. There we go. This should work. I believe. I believe. And that's all that's needed for computing to work. Yes! Okay. Still, it's a pretty ugly way to do it with a flag, but maybe we'll refactor later. Next. Translate stops if stop codon at beginning of sequence. Oh, let's see what's going to happen with that. Should work. Our little flag system is, yep, takes care of that. Translation stops if stop codon at end of 2 codon sequence. Yes. Translation stops if stop codon in middle of 3 codon sequence. Yeah. Should all work with that. And finally, translation stops if stop codon in middle of 6 codon sequence. Yep. I believe we are about done. Skip 2 tests. What am I skipping? Oh, this one. What's the other one? Oh, okay. And we pass all tests. Yes, the crowd goes wild. Okay, quick refactoring maybe. So I don't need this anymore. We've got our protein map. Got our class here with the static proteins. So this is the thing that I think we should refactor, because right now we're iterating through the codons array. Even though we don't have to, at some point we just hit a stop, and we should just really stop iterating at that point and just return whatever we have, but we keep going saying, oh, I shouldn't do anything with this, I shouldn't do anything with this. So really, extra computing for it's not a big deal, but let's pretend we had like a crazy long RNA sequence that would take hours to compute for some reason, and it wouldn't be very efficient. So let's see if we could do something better. Now, the only thing I think that would work, since you can't escape out of a... Can you escape out of a reduce at some point? It's worth checking out. Let's just ask Google. Can you escape out of a reduce? Of array dot reduce. Reduce. How to break unreduced method. That's pretty much what I'm asking, I guess. How can I break the iteration unreduced method for break? Go update. Some of the commentators make a good point that the original array is being mutated in order to break early inside the reduce logic. Therefore, I've modified the answer slightly by adding a slice. Wow, that doesn't seem very... Slice 0. Okay, so he's basically making a new array. in order not to mutate the array, but he's still mutating that array, apparently. If I equals array that's place one, eject early. What? You can break on any iteration of a reduce invocation by mutating the fourth argument of the reduce function array. The fourth argument of the reduce function array. Right, okay. Yeah, that doesn't seem right. You can use functions like sum and every as long as you don't care about the return value. But I do care about the return value. There is no way, of course, to get the built-in version of reduce to exit prematurely, but you can write your own version of reduce, which uses a special token to identify when the loop should be, which is kind of what I'm doing, except I didn't go through the trouble of making it a function and all that, but and I'm still using the reduce. So that seems overly complicated for no reason. I'm not going to be reusing that code anyways. I think we're going to have to use a loop. Yep. Okay. Let's see what that would look like with a loop. How about we make it for... Still use our flag here. Oh, didn't want to. So let's make it a while loop, maybe. Haven't done that in a while. Although if I do it that way, I don't have access to. No, let's just do that. For each protein, no, each codon is what we're interested of codons. We're going to, we're going to do this here. I think should work. We're getting our protein if stop is equal true. Actually, I don't need that because once I hit stop, I just break out of it. So I don't need that check anymore. All I need to do is break. I do need to make a proteins array though, so const proteins equals new array. Let's just make it like that. We'll type it. We'll type it. There you go. Break. Otherwise, proteins dot push. How's that? Let's run our tests. Suspense. No, they all failed. Why? Because I'm not returning the proteins array. That's why. Yes, that would be a good reason. Okay. Take two. Yeah, okay. So how's that? What do we prefer? This here, because that's what we're comparing really. This here, or this here. I think this is better. So that's what we're going to take. Not only is it shorter, doesn't use a flag, doesn't do extra computing, unnecessary computing. So let's think it's pretty good solution. How about readability? Should we extract functions out of this to make it more readable? Well, it's often good to extract conditionals like this. But we're breaking out of a for loop here. Can you extract a break into a no? I don't think you can do that. It's just, you know what? I think we're just going to leave it like that. I think it's a suitable solution to the problem. It's relatively readable. All we've got is the one if statement, which is pretty obvious. If the protein is stop, you stop, right? Otherwise, get your proteins. Satisfied. So now, what do we do to push this again? We submit, exercise, submit, yeah. So it should be as easy as exercism, submit, submit, yeah, and what's the name of the file? Protein, protein dot, no, not translation, dot ts, okay. Did I not do this properly? Exorcism. What is it again? Oh, yeah. Sysm submit protein translation.ts. There you go. Let's see if that worked by just refreshing. And our solution is here. Yay! Let's ask for some. Oh, I can't ask for mentor feedback. No, why? You may request mentoring on up to 3 non-core exercises per track. Once your existing non-core solutions have been mentored. Oh, okay. I'm sad now. I'm gonna wait for some mentor to mentor my other exercises before asking for mentoring on this one. But I still think we can keep going with another one. Do I need to wait to get in progress unlocked? I think we can move on to another one, shall we? Oh, looks like we're staying in the realm of DNA stuff. Yeah. Nucleotide count. Nucleotide count. Oh, first, let us push that to get, commit to get. Is that? Yeah, it's our protein translation. Yeah, okay. So add solution to protein translation. Thank you. Can even send that to GitHub. I've got that on GitHub. Won't be needing this. Needing this. All right. What are we doing? Given a single-stranded DNA string, compute how many times each nucleotide occurs in the string. And I remember that these are these nucleotides? I dealt with nucleotides before in RNA transcription. Yeah. These are DNA nucleotides. These are RNA nucleotides. So, given a single-stranded DNA string, I don't know what that means, single-stranded. Oh, just Anyways, compute how many times each nucleotide occurs in a string. The genetic language of every living thing on the planet is DNA. DNA is a large molecule that is built from an extremely long sequence of individual elements called nucleotides. 4 types exist in DNA, and these differ only slightly and can be represented as the following symbols: A, C, G, and T. Here is an analogy. Twigs are 2 birds' nests, as nucleotides are to DNA, as Legos are to Lego houses, as words are to sentences. Okay, yeah. Interesting. So that seems pretty easy. All we need to do is parse the string and somehow count how many A's we have, how many C's, how many G's, how many T's. Yep. So shouldn't be too hard. Let's get back to our root TypeScript folder. Download our exercise, which is called, what's it called again? It's called nucleotide count. Okay, let's get in there. Install dependencies. Let's commit this. Add nucleotide count. Exercise. Don't need the RNA. Actually, I think there's something I could use from there. Let's see. If I remember correctly, I had a little type DNA nucleotide thing. That should be fun. Let's use it. Let's go with nucleotide count. There it is. Okay. I don't know if it'll be useful, but it'll be available. Okay, let's see. Let's take a look at our tests. Count all nucleotides in a strand. It wants an object with keys equal to our nucleotides, our DNA nucleotides, and then a number. Seems easy enough. It's calling the nucleotide counts function with a string. Yes, okay. So let's make that DNA strand is a string. And we need to return what's that? Should I make this a... That's making things complicated for no reason. Let's just put it in there. We need an A. That's how we're going to initialize it. It's quite simple, but we don't really need more than that. G 0. Let's add a space here. Oh. And T. That's something it doesn't like. What am I doing wrong? Left side of comma operator is unused and has no side effects. Oh yeah, because it's not figuring that it's an object. It's thinking that I'm doing some kind of statement, but no. Const, yep, it's going to be, what are we going to call this? Count? How's that? There we go. Alright, now we need to parse our string, and every time we end up seeing an A, we just add to that count. So how do we do that? How do we iterate on a string? Well, we can do, I don't know why there's not a for each, or is there? There really should be. Length, split, replace, value, trim, substrings, Well, let's do this then. Array dot from DNA strand. Whoop. Array dot from DNA strand. There we go. And then we can do for each. And our value is our nucleotide. And it'll want me to do this. So nucleotide. And now we need to have some sort of, let's see, count. Yeah, that should be pretty easy. We just do count. If I can type properly, count. Oh dear. Okay, count nucleotide plus equals 1. Should that should work. Element implicitly has an any type because type has no index signature. Yeah, encountered that before. I know exactly what to do. So, oh, actually, let's try this. See, now, usually I would do index. No, not index. Key, right? Key. And then of type string, which is fine. But I can actually, because I know which ones they are. Index signature parameters cannot type a union. What? I think I need to do this now and go string. No, number. It's not working. No space. Okay, no space. An index signature parameter type cannot be a union type. Consider using a mapped object type instead. Ooh. Okay, fine. Let's just go with the string. I'm not going to be using this then, I guess. This should work. Pretty sure this should work. This is a relatively easy one to solve. Or maybe it won't work. Maybe it won't. Because I'm not returning it. Again, what is up with me not returning stuff? Still doesn't work. Still getting undefined. What? Because I'm returning. Yes. Okay. This is what I need to return. Hey boy. There we go. And pretty sure it'll work with all our other tests. So let's just go ahead and activate all of them. Oh, we've got a problem with strand with invalid nucleotides. Aha! Yes. Yes, yes, yes. So what are we expecting here? If we want to throw an error if this doesn't work. Okay. What does it normally do if it tries to get, did it somehow return, what did it do? Expect function to throw an error with string this, but it didn't throw anything. So it just went ahead and, what happens when you try to get a key that doesn't exist? It doesn't throw an error? You would think it would throw an error. It just returns undefined. No, that wouldn't make any sense. You know what? Let's experiment. Let's experiment with our trusty browser console. So let's make ourselves an object with a key of foo and a value of 1. Boom. Whoops. Gotta get that equal sign in there. Okay. And now we're gonna go object. Let's get the, oh, it knows. It's so smart. And that works. But if we are to go and say, let's get the bar key property, it just returns undefined. It just returns undefined. Can we use that behavior? Yes, we can. Const nucleotide count. So okay, let's make this counts. And now let's call this nucleotide count, or just count. Yeah, now this is making me think that it's not a great name. Then I can't use this because this is the name of the function, so or can I? What would happen if I try this? Something bad, no doubt. Maybe not. Maybe not. We'll see. Because I really like that name. That's, oh, it's not the same. Okay. So const nucleotide count is equal to, I want to get this here. Nucleotides counts. Nucleotide. Cannot find any did you mean nucleotide counts? Nucleotides. Nucleotide counts. Nucleotide, cannot find any nucleotide. Well, of course, because why am I doing this outside of the, that's funny. I gotta do this. like that. And once that's done, if nucleotide count is oh, it wants us to throw, right? What am I doing? That's not what I'm supposed to be doing, is it? I just need to throw if I get something that's not in there. Yeah, making this way too complicated. So let's get back to where we were. Although the renaming is wow. Okay, I'm still gonna need to do another line though. Just get if nucleotide, no, if count, nucleotide. Oh, I think that's why I was doing. Because I am evaluating it twice now, that's why I was setting myself up for just being able to evaluate evaluate it once, which really is a good thing we should do. So let's do it. Nucleotide count is equal to this here. Now if this is undefined, don't do anything. Actually, we just return, I guess. Return. I'll short circuit it, and if it isn't, then we can just go ahead and do nucleotide count. Oh, you know what? There's no getting around. There's no getting away because I'm just extracting the number here, and that's immutable, right? If I would do here, I'm not actually changing the nucleotide count. Yeah, that's right. I can't because I made it a const. So, but even if I was making it a let, I'm not assigning that to. Where am I? Let's see. Yeah, no. So I'm going to have to do that twice anyways. So might as well not have this extra line. So if we get undefined, return, don't do anything. If we don't get undefined, then we can do this. Ah, this is so annoying that I have to. Oh no, I forgot. We are not returning, we are throwing. Just throwing. Throw, a new error. And our error is going to be Invalid nucleotides in strand. Okay. Oh, interesting. Count all nucleotides in a strand with multiple nucleotides. So that didn't work. What did we get? Invalid nucleotides in strand. I'm just throwing every time now. Apparently. Strand will replace this strand with... The empty strand worked. This worked. If count nucleotide is equal to undefined. Oh, would that change anything? It's basically the same thing. Why? And that worked. Okay. Apparently my understanding of why wouldn't... I am confused. I am confused. But whatever works, I guess. Still though, why wouldn't it work? Why wouldn't this be the same thing as what we just did? As equal undefined. Because if it's equal undefined, undefined is a falsy value, right? Eh. Okay, so this works. Should we refactor? What else could we modify here to make this more readable? I guess this is taking up a lot of space for no reason. I could just have it like that. Not less readable because of that. I don't think so anyways. All right, what about this here? If count nucleotide is equal to undefined. Throw new error, count nucleotide plus equals 1. Let's extract this and make this we'll call it is not a valid nucleotide. So, if nucleotide count is not a valid nucleotide. It's kind of too bad that count nucleotide throw new error, invalid nucleotide in strand. Okay, so now we could, how about this? Oh, but this doesn't make any sense because we're using a static So let's just keep it simple and just submit this. Exorcism submit nucleotide count dot ts. There it is. Don't need you anymore. Thank you. All right. Maybe time for one more if it's simple enough. Allergies. Allergies. Given a person's allergy score, determine. Just gonna check something here. Okay. See how it's pretty neat. It tells you what you're going to be working on in terms of concepts for the core exercises anyways, but it doesn't seem to do that for these side ones. Okay. Given a person's allergy score, determine whether or not they're allergic to a given item and their full list of allergies. Oh, I'm seeing enums. Okay. An allergy test produces a single numeric score which contains the information about all the allergies a person has that they were tested for. The list of items and their value that were tested are. So if Tom is allergic to peanuts and chocolate, he gets a score of 34. Oh, no, that's weird. Peanuts is a 2, chocolate is a... Okay. Now given just that score of 34, your program should be able to say whether Tom is allergic to any one of those allergens listed above. Or all the allergens Tom is allergic to. And, okay, so... Note, a given score may include allergens not listed above. Allergens that scored 256, 512, 1024. Your program should ignore those components of the score. For example, if the allergy score is 257, your program should only report the eggs, one allergy. Oh. And they all seem to be in base 2 binary. Am I gonna have to do some bitwise operations and stuff? Oh man, I suck at that. This may be more complicated than I thought. But interesting though. It'll be a nice learning experience. Let's see. Well, let's start by downloading it, I guess. Yep. Let's do that. We're done with this here. Oh, first I should nucleotide count. Nucleotide count. Add solution to new what's it called? Nucleotide count. Okay. And this will be add allergies, exercise. Allergies. Oh. to install our dependencies. It's using Jest for the tests. That's why it's highlighting it as an error right now, because there you go, it's installed now. From allergies is not a module. Yes, it is. Or maybe it isn't. I guess we need to implement it. Oh, it's the first time they get us to do that. Usually they supply some kind of base text, base code, I mean. So what is our text expecting? It's expecting a class. It's constructing a class with a constructor that takes a number. Okay, so let's start with that. The class is called allergies. Export class allergies, which takes a constructor. Constructor that we're going to pass score, right? Score. Let's make it a private score, which is a number. We don't do anything with that. Oh, probably doesn't like the. No, that's cool. Cannot be declared in the constructor. No parameter properties. What? Why would you? I love doing that. Why would you have that as a linting rule? No parameter properties. Disallow parameter properties in class construction. Why would you do that? I love doing that. Oh well. Let's be or maybe let's not be obedient and just switch it and see what the mentors say, if they say anything. I should ask about that. In fact, I will. There a reason why the no parameter properties is set set to true in TSLint. I love. What's the? Cannot be declared in the constructor. Yeah. Yep. I love declaring properties in the constructor. Let's see if we get an answer to that at some point. Okay. For now, let's play along. We're going to call this score. It's going to be of type number, and it's a private. So now we're just going to call this score. Like that. Good obedient coders is equal to our score. See, why would you go through all this when you can just go private score? Boom. Oh, now what? Okay, yeah. Okay, and what else are you looking for? Allergies that allergic to And this takes in a string. A string of what? Things you can be allergic to. Allergens is, I believe, what they are called. Allergens. Or just one. Allergen. Right? Only one at a time, I'm guessing. Oh no. I think you can get... Oh no, that's the expected output. Import allergies. Has no default import. You in your default. Export default. Would that work? Class, yeah. Happy now? There. Or I could just change the test. I won't. Okay. Allergic to... What are we returning? What are we expecting? We're expecting a Boolean, right? We're checking to Boolean. So give me an allergen. I'll check the score, and then I'll check if this is, yeah, okay. No, I still think an enum would work for our list of items. Can I shove that in here? Could probably make it a static. That would make sense, right? Static. Allergen score. Allergens score. How do I... enum scores equals... Remember enum implicitly as a type, as an any type. Well, what if I do this? If I do, let's copy this here for now. Shift Alt A. Boom. Eggs. 1. Unnecessarily quoted property eggs. Alright. I shall oh. Yeah, that's not. I don't know if you can, let's see, static. Not sure what the proper syntax would be here. Let's see. TypeScript. TypeScript static enum. Enum inside class. That is exactly what I want to do. Can you set a static enum inside of a TypeScript class? This is more recent. Oh, I like this though. Enum is a way to const enums, export enums, string enums. Doesn't seem to have the answer here. Search around, but can't seem to find an answer for this. Hopefully you can. How can I add an enum to an image? Right? That's exactly what I want to do. Opt into this problem today. This is what I am currently using as a solution. Is probably declaring the enum outside of image.state. Oh, that is ugly. Using namespace instead. Yeah, this is probably more what I would do. TypeScript does not allow defining an enum inside a class. What an awful language. Yeah, it would be nice though. Why? There must be a reason why they don't allow it, but... So let's do it that way then. What are we calling this? We're calling this enum allergen score. Suppose that. Now I can do I need the, let's try it, see if, wait, see, equals 1. Eggs peanuts equals 2. Well, you know what? Oh, silly. This equals like that. Get rid of this. Okay. Static allergen score is equal to allergen score. There we go. Although we don't really need to access it in the tests. I could have just not bothered about making it a static class. So maybe I won't. Static method, I mean. Right, now the complicated part is figuring out some kind of algorithm to go from how do we know if he's allergic to peanuts? Well, first we can just go so here's the thing. Let's say we have a score of 32. That means that we're allergic to chocolate, right? But if we have a score of, let's say, 36, that means we're allergic to shellfish. Okay, if we had a 37, got the 4. Oh yeah, so I just go down the list in terms of numbers. Get the highest one. Can't help but think that there must be some sort of a way to use bitwise operations for this. Binary, because that's essentially, we're looking at a bit here, aren't we? Or a byte, should I say? God, I suck at this stuff. A byte is 8 bits, right? So, well, you guys can't see this, but could I do this on screen? Is there some sort of a, let's see, let's just use WordPad, I guess. WordPad. I would do this by hand, but so a byte is basically a series of 1, 2, 3, 4, 5, 6, 7, 8 bits, which are either 1 or 0. And oh, this is not the right tool to do this, but essentially we've got 1, 2, 4, 8. Okay, this is driving me crazy. Nope, let's see if we could use paint instead. There we go. Okay. Let's make it thicker. Their way, yes. Here. Oh, can't I have a bigger one? Whatever. All right, so 1, 2, 4, 8, 16. So I'm gonna be clear. Is there a way to clear the thing? I don't want to use my small eraser. Select. Okay, select. And then just delete. Okay. Start here. So 1, 2, 4, 8, 16, 32, 64. Oh, man. 128. 1, 2, 3, 4, 5, 6, 7, 8. Right, and that's equal to our numbers in our enum. And now what we need to do is, let's say I have a score of 32. Well, I could represent that with 0, 0, 1, 0, 0, 0, 0, 0. Right. But if I add a score, oh, there we go, it's all coming together. If we had a score of a 36, how would we represent that in binary? We would represent it like this: 0, 0, 1, and then 0, 0, 1, 0, 0. So how can we quickly check now if we are allergic to peanuts or whatever well, we just look at the bits. I just don't know what if there's a bitwise operation, if there's I'm gonna have to look that up, because I know about nothing in terms of bitwise operations and using binaries and code and stuff like that. So this will be interesting. But we're about out of time for today, so we might look into that tomorrow. I will, in any case, I'll be streaming at 9 a.m. Eastern Daylight Savings Time, and we might continue this solving this, or maybe work on some other exercise or some other thing. Thanks for watching, guys. See you tomorrow.